In this Python tutorial on astronomy and astrophysics, our objective is to learn that how to create a mock or any simulated astronomical sources objects such as stars or galaxy. So here you can see that I have already created a synthetic image of astronomical sources. So this is my star, which looks like a point and which has some spread due to the point spread function of the telescope. And this is my elliptical galaxies. Okay, so these are my synthetic images, but it mimics like the actual image taken from the telescope. Okay, so now the question arises like, why do you need to create such fake images and how it will be helpful? So let's dig out. So in order to know that, why these images may be helpful, so these images may be like used for your testing, calibration, and analysis in astronomical sources without relying on your actual telescope data. So let's discuss some points like why do you create astronomical images. So like one thing can be like you test your data analysis pipeline. So these images may be used to validate image processing technique and your data analysis technique before applying to them to your real telescopic data. And you can also simulate observations, so it helps astronomers predict like what a telescope will see under different sky and different seeing conditions. And with through these images you can like also calibrate your instrument and detectors like how it performs against these objects. And you can also use this data set to train your AI model through machine learning, and you can do classifications such as stars or galaxy or detection etc. So in order to do these mock images of galaxy and stars, I have defined some steps in which we'll be proceeding. So first of all, I will be importing some necessary libraries, say NumPy, Matplotlib, Astropy, modeling etc. And then I will create a canvas for image size and pixel size. After that, I will create a star image with Gaussian modeling, and after that I will create a galaxy image with Sarsic modeling function, and then I will combine both the star and galaxy in a single image, and then we'll visualize the images using Matplotlib, right? And after that I can save this image in a fits format, right? So that you can use it at later time for your analysis. So let's do it. We can begin our actual coding stuff. So let's go to step 1, right? So we'll be importing our required library. So first of all I will import numpy as np. So this deals with number and arrays. Okay, then I will import matplotlib dot pyplot as plt. So this deals with your data visualization, right? and then I can import Astropy modeling, right? So Astropy modeling. So from Astropy, so from Astropy dot modeling dot I will import some functions, right? So functional models I will import here two like models. One is uh, Gaussian 2D, right? And then Sarsic, okay? Sarsic 2D, right? So this deals to your mm, modeling, right? Modeling of a star plus galaxy, right? Now, what is mistake here? There should be import, okay? Now fine. So our step 1 is done. We have imported 3 libraries. Now I will create a canvas for plotting these mock images. So I basically will like image size and how much pixel it has, right? So I will define image size. So you can give here say size equal to say 300 pixel, okay? Image pixel size, okay? So it becomes 300. Now what I will do, I will like create a mesh grid, okay? So this is like it will get a canvas, okay? So now create a 2D mesh grid, okay? Mesh grid, right? So for that type here x comma y equal to np dot mesh grid, right? And then you can like arrange your numbers, okay? So np dot arrange 300, right? So it will go from 0 to 299, and then again the y np dot arrange 300, right? So this will create, you can check what is my this np dot arrange 300, right? So basically this gives like a pixel number from 0 to 299. So total is 300 size of x and y, right? So like you print here x, you can see it has like this is like a row from like 0 to 300 every rows, and similarly you will have like columns, okay, for every. So basically this becomes mesh grid for your image, 2D image, like which contains row and columns, okay, like 0 0 0 1 0 2, like that. So two things we have done, right? And you can also check the shape, like what is the shape. If you look into that, you can see 300, okay? This means that my image pixel size is 300 into 300, right? Now I will create a star image with Gaussian 2D model, okay? So basically what happens, your star is a point object, but when the light passes through the telescope, so the light interacts with the telescope optics, and the image of the star get blurs, or like it gets spread, okay, through the optics of the telescope, right? So this is like how a star like appears to be a spread, okay, rather than a point object. So for that we will do like Gaussian model, like at the center we will have a peak, and as it goes through the passes with the like pixel, the intensity gets dropped. So for that, hit a star, okay. So a star can be here, right, variable, and then you can give a Gaussian 2D model. See what it takes. So it takes your amplitude, your x mean, y mean, because like we are giving a 2D model, your x standard deviation, y, and theta, like how much it is rotated, right. So let's give it. So you can give amplitude you can give say 5, right, 5 unit, and then you can give x mean, I mean like where the center of this image will like. So you can give say uh, to like 200, and then y mean also 200, right, and then you can give x deviation say 5, y deviation also 5, and last it will take your theta, okay. So let's assume like it's like a circular, so nothing to give that, right, and see into the star what it turns. So you can see here the parameters, and we have like theta equal to 0, so no rotation, right. So and then I will get my star image, okay. So create a star image from model, okay. So you can make here a star image equal to, and evaluate this model for different x and y, okay. So you can pass here a star, and you can pass here x comma y, okay. So my star image has been created. Now you can plot this, you can like see the star image what it runs. So you can see their numbers, okay. So again like there are 0, there are some non-zero numbers, and you can see it's shape. So shape is 300, 300, right. So I'll go to here. Now I'll create a galaxy image with a Sarsic model. So you can see the Sarsic model can be visualized with this plot. So it contains some parameters like it contains amplitude, your effective parameters, its Sarsic index, and its position, and you can also give its ellipticity and how much this image is rotated, okay. So let's give that. So get galaxy model, okay, and you can give say Sarsic, right. So Sarsic 2D, and see what it will take. So to take amplitude, R effective, your coefficient, your x0, y0, ellipticity, and other stuff, okay. So you can see what these parameters are. You can see your effective half rate radius, surface brightness, your positions, your ellipticity and theta, like how much it is rotated, and xy are the position of the object, right. So let's do that. So type here amplitude you can give say 0.5, you can give it, and then you can give your R effective, you can give say 50, and then you can give say n equal to, you can give say 4 for decoupler profiles, or say I'll put 3, you can change it later, and then you can give your say x0 you can give say 100, and y0 you can give say 100, so symmetric, and then you can give theta equal to, you can give say convert from degree to radian. So mp dot degree to radian, and you can read by 45 degree, right? So this is what my model turns. If you type here galaxy, right? This is why my parameters are, right? And after that you can create your so now create galaxy image data as 2D. Okay, so 2D. So you can type here, say galaxy image equal to galaxy, and evaluate that model at each x and y. Okay, so this is how my term, and see what is data returns. Galaxy image, so here is my data, right? And you can also check the shape. So if you check the shape, it is same as 300, right? So I will just put the data. Now combine a star and galaxy image. Okay, so for that make here like final image, or just call it mock image equal to a star image and plus galaxy image, right? So you can print it what it looks like, mock image. So this is how my data looks like, right? And then I will plot this mock image. Okay, so for that use a command plt dot image show, and you can pass here mock image. Okay, you can make origin, make image, and then origin equal to lower to make your pixel origin at 0 at lower left, right? So here you can see that I have only one image is looking, right? So maybe you can go to the min max. Okay, so visualize better, so go here, v min, you can get here say 1.1, and v max you can set it to 0.4. Okay, so there is mistake, so there should be either way, right? 0.4 and then make it 1.5. so here you can see that you have this star and this is the galaxy. Okay, so you can make some changes, okay, in this image. So just change this parameter as a 5 and see how it returns. So you can see this is changing, and you can make it more, say you want to make it say 500. So this is how it appears, and you can also like change its electricity if you want. So you can change its electricity, you can give as a 0.5, right? So maybe we need to change other parameters, make it 50. Yeah, so here's my image. So here you can see that this is my star image, right? This is my elliptical galaxy image. You can see the star is a point, but like due to the point distribution of the telescope, this object has dispersion of the light, and its lights are spread over the pixels. This is my image of the galaxy. Okay, so this is how you can do it. You can like now you can also like make more images of the galaxy if you want. So what I will do, I will like just yeah, so I think you can use a for loop. Like once you like learn that how to do create these images, then like it's very easy. You can use for loop to like get the more images. Okay, so now what I will do, I will change some parameters. So you can change the angle if you want. So change this angle 90. See how the image looks like. See, image has got this one, right? You can put it 0. See how it looks like. So it is how it appears. So you can like play with the parameters. I'm not going to do that because it will like wasting time. So you can like visualize your own way, and then I will like save this image in a fits file. Okay, so you can add here. You can write a command here, fits dot write to. Okay, and then you can give my say mock, give my file name say mock image dot fits, and you can give my data equal to say mock image data and overwrite equal to true for like overriding your data like every time you run. Okay, so I think that's not defined. Okay, so go to the above, right, and add here one library, right? So you can add your own library from astropy.io import feeds. Okay, so this deals with your feeds file input and output, right? So let's run this. See, this has done. It means it has been saved successfully in my directory. So let's go and search this image. So mock, so control F, mock image.fit. Okay, or maybe just you can check it here. If you type here ls star fits, so here is my, okay, so here is my image. Okay, so it has been on 27th 02 25th and at time, and you have this sizes, and this is like your file name. So what I can do, I can open this image in the DS9. Okay, so let me go to and open my DS9 software. Okay, so my DS9 has opened, and then type here Control O, and then go to my document coding and search for mock image.fit. Okay, so upload it, and then go to your zoom fit, go to a scale, get a scale. So here you can see, here's your image, right? And you can give different colors if you want, right, to visualize your object. Okay, this is how your object looks like. You can also like change the contrast. Okay, so like how your intensity varies and how your object appears. So this is how it is done. So let me close this DS9 and go to my coding stuff. Okay, so this is my final product, right? and you can so I'm expecting that you have learned these stuff with me, and I can review this code once again what I have done. Okay, so basically I have done the 5 steps. So step 1 is like importing libraries, say NumPy, Astropy modeling, Matplotlib, right? So there should be PLT, and then you can create a image size or canvas. Then you can get a galaxy or star image. Then you can get a final image by combining galaxy and a star, right? Then you can visualize using Matplotlib. Then you can save this image as a feed format, and you can open in DS9 to analyze it. Now this image is ready to do any modeling you want, or if you want to extract any parameters. So thank you, and I hope you have enjoyed this video. So stay tuned for next video. Thank you.